Welcome to our demonstration of Kubernetes. We want to give you some insight into the capabilities of a Kubernetes clusters with respect to your applications. So we've started up a Kubernetes cluster, and I have the Kubernetes dashboard running here. You'll see that it's fairly lightly loaded at the moment. If we take a look at the nodes, you'll see that there are 5 nodes that are available here for us to schedule work onto, and this doesn't include the control plane for the cluster. These are just the minion nodes that we can schedule work into. But this is kind of unintuitive. So we have a visualization tool. This is a tool that was created at Samsung by the Cloud Native Computing team. And this allows us to drill down into nodes and see what they're actually doing. For example, here we're running Influx and PodPincher, which is this tool. Prometheus, our metrics collection, Heapster, also related to metrics. And it allows us to drill back out and see the entire cluster at a glance. And as you can see right now, it's fairly idle. So to make this demo somewhat interesting, we want to create some load for our cluster. So we're going to do that by starting up our load test. And you'll see right away that the next time this refreshes, all of a sudden we have a bunch of load generation framework, load generator, all running on our node. We can drill down into that and see the resources allocated to it, and then scale back up to our entire cluster view. So let's say we've been doing some work on a application based on BusyBox, and we're happy with that application. We want to deploy it to our cluster to test it. So we've created our container, and our container has been uploaded to a registry. And now we want to deploy it into the cluster where previously we may have only been running it on our laptop. So we'll do a kubectl create. And for now, we're just going to run our pod. So a pod is basically a single, the minimum instance. And we've scheduled that. And this bright orange instance here, this is our BusyBox pod. So if we drill down in there, there's our pod running. Now, we've done some testing and we've exposed this service to our friends and they say it looks good. We're going to go ahead and leave our test application running, but what we've decided we want to do is scale it up. So now we have a service, and the service relies on a replication controller. We want to tell kubectl to create our service. And we're going to start off initially with just 3 replicas. So as we go back now, we should see our cloud our cluster start to include our service. So there's our BusyBox service now. And it's running on 3 different nodes. So it's distributed across the cluster fairly evenly. So after a small amount of testing, we decide that our service is really successful and we like it a lot. And so what we want to do now is we want to scale it up. So we're very happy with it. We think customers will like it. So let's say we need 10 instances to handle all of the expected traffic. And so you can see now we start to get a better distribution of our BusyBox service running on all of the nodes in the cluster. And that was so successful, let's say now we need 15. Because the service is just becoming more and more popular, and quickly our cluster adapts. So with that much usage, we find that there's been some issue and there's a bug that's been detected. So we do some development internally and we push a new version of our container instance to our registry, and now we're going to update our image version of BusyBox. And without taking our application down or having any service unavailability, we're going to do a rolling update of our service to our new version, image BusyBox 1.24.2. So this is going to roll out to our cluster. And you're not actually going to see, we don't have a different color to show the cluster, but you will see it shift shape as the old pods terminate and the new pods replace them. So you'll see that slowly we're replacing them. And I set it up to roll out at a 2-second interval, so we don't want to make a massive change all at once. But slowly over a period of time here, our entire cluster is going to sync up to the new version of the application. Should have done a shorter interval to make this go a little faster with 15 instances running in our cluster. So we're up to 11. And if we wanted to, if we decided that our service had spare capacity and we wanted to scale it down, we could change our replica number to be any smaller number and it would size it down. So our rolling update is completed. We're now running on version 1.24.2 and that's been deployed to our cluster everywhere. So let's say that for some unknown reason we have a SSL bug or some other reason that our cluster operations team decides they have to reboot one of the servers in our cluster, and I just randomly picked one of my auto-scaled nodes. Now we could go in and we could tell Kube Control to drain this server so that it has a chance to move this work off, but this also simulates a network partition or any other type of failure that could occur in the cluster. We'll just stop this, and you'll see that as that node disappears, the cluster is going to rebalance, and our 15 replicas are going to go to other nodes. So it's going to take a little bit of time. We'll see it here in just a moment. We still have 4 auto-scaled nodes. So once it recognizes that node has gone away, you will see that it will remove it from the cluster and rebalance the work. The important thing to note here is that the entire time our service remains available. There are several pods scheduled onto the node that are unaffected, and there was our rebalance. We're down to 3 auto-scaled node and our primary node, and our number of BusyBox services has remained constant, as well as our load generator application that we started at the beginning. So we decide after time that we don't need 15 replicas. We're going to shut it down. We're going to roll out a new, better service in the future. So we're going to take our scaling service, and the instances take some time to terminate, but as they terminate, they will start to drain out of our cluster. So that's a brief introduction to the capabilities of Kubernetes for application development and deployment. I hope that was interesting.